Alright, so today we are going to be graphing exponential functions. So the exponent rules that we've been using is going to kind of apply to this. But we're going to be putting them in graphs now. Okay? And so an exponential function is written in the form of y equals a times b to the x power. If it's an exponential growth, the b is going to be greater than 1. Okay? If it's an exponential decay, the b is going to be in between 0 and 1. It's like a fraction. Okay, and if you guys look, when it grows, when it's an exponential growth, it literally grows. When it's a decay, it decreases. Okay, it's always going to be curved. So, the general form is usually y equals a times b to the x power. And then sometimes they add a k, which is our constant rate of change. But in this case, it's going to be our horizontal asymptote, horizontal like the horizon. So the things to remember that if a is greater than 0 and b is greater than 1, then it's a growth function, so it's going to be growing. If a is greater than 0 and b is in between 0 and 1, it's a decay function, so it's going to be decreasing. And then if a is greater than 0, then it's neither a growth nor a decay. And then your horizontal asymptote is y equals whatever your k value is. If there's a value being added onto it, then that's going to be your asymptote. If there's nothing being added onto it, what do you think your asymptote is? 0. So that would be your x-axis. Okay? And this line will never cross your asymptote. Never. Okay? It will always approach it but never cross it. Okay, so how do we do this? First, we find and draw the asymptote. So we're just going to draw a line so that we know it's never going to cross that line. Then we're going to make an xy table and pick 5 values for x. I like doing -2, -1, 0, 1, and 2 to make sure that it crosses my y-axis. Then we're going to substitute those values in for x and solve. Plot the points, draw the curve. Okay? Okay. You might need a separate sheet of paper to do these problems on, or the back, or something, because there's a you have to do each problem. Okay, so is there anything being added on to this equation? No. So my horizontal asymptote is y equals 0. So that means that my graph is never going to cross 0, my x-axis here. Okay? So I made an xy table. I have my values -2, -1, 0, 1, and 2. I'm going to substitute these values in for x in my equation and find y. Okay. So we're going to have y equals 3, and instead of x, I'm going to substitute in -2 to the -2 power. So then y, we have a negative exponent, so that's going to become the reciprocal. And then 3 squared is 9. So we're going to have 1/9 for my y. So at -2, this is going to be approximately 1/9. This is literally slightly above my line. So it's almost 0. It's like 0.111. When you're plotting, it doesn't have to necessarily be perfect, okay? Because you're giving me the value here, so I know what you're trying to do. Okay, now we're going to substitute -1 in for x. So I'm going to have y equals 3 to the -1st power. So that's going to be 1/3. Which is literally going to just be slightly more above. Because it's like 0.3 repeating. Okay, now we're going to substitute 0 in for x. So that's y equals 3 to the 0 power, and anything to the 0 power is 1. So at 0, we're at 1. Now we're going to substitute 1 in for x. So 3 to the 1st power is just 3. So at 1, we're at 3. 1, 2, 3. And then we're going to substitute 2 in for x. So 3 squared is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we're going to draw our curve. So our graph is going to constantly approach this line but never cross it. Okay? And then it's going to go up forever. It's literally going to get closer and closer and closer to 0, but it never will reach 0. All right, let's look at the next one. Is there a value being added on at the end?
Yeah. No.
No, there's nothing being added, so my asymptote is going to be 0. So, our graph is never going to cross the x-axis. So now I'm going to take my points and I'm going to substitute them into my equations and solve for y. So I have y equals 2 times 1/2 to the negative 2 power. So that's going to be the same thing as 2 times 1/2 to the negative 1, 2, negative 2, which is the same thing as 2 times 2 squared over 1 squared. So that's going to be 2 times 2 squared, which is 4. 2 times 4 is 8. So at negative 2, we're at 8. 1, 2, 3, 4, 5, 6, 7, 8. Plot my point. So now we're going to substitute negative 1 in. So y equals 2 times 1/2 to the negative 1st power, which is the same thing as 2 times 2 over 1, which is the same thing as 4. So 1, 2, 3, 4. Okay, now I'm going to substitute in 0 for x. So that's going to be 2 times 1/2 to the 0 power, which is 2 times 1, which is 2. So at 0, we're at 2. Now I'm going to substitute in 1 for x. So that's going to be y equals 2 times 1/2 to the 1st power, which half of 2 is 1. Now I'm going to substitute 2 in for x. So y equals 2 times 1/2 squared, which is the same thing as 2 times 1 squared, 2 squared, which is the same thing as 2 times 1/4, which that would be 2 over 4, which is 1/2. So that value up there is 1/2. So it's approximately there. So again, our graph is going to approach 0 but never cross 0. And this one is a decay. Okay. Is there a number being added on to our equation?
Yes.
Yes, 1. So my horizontal asymptote is at 1. So that means that my graph is never going to cross 1. So it's going to approach 1 in some direction. So now I'm going to take my values for x and substitute them in and find y. So I'm going to have y equals negative 1/2 times 4 to the negative second power plus 1. So that's going to be negative 1/2 times 1/4 squared plus 1. So that's going to be the same thing as negative 1/2 times 1/16 plus 1, which that would be negative 1/32 plus 1. And 1, we can make that 32/32. So 32 minus 1 would be 31/32, which is almost 1. So that makes sense, because it's going to be almost at 1, but not quite there. So now we're going to substitute in negative 1. So I'm going to have y equals negative 1/2 times 4 to the negative first plus 1. So that's going to be plus 1. So that's going to be equal to negative 1/2 times 1/4 plus 1. So that's going to be the same as negative 1/8 plus 1. So I can make that 8/8, and 8 minus 1 is 7, so 7/8, which is a little bit further away from 1, but still almost there. Not quite at 1/2 though, so it's just kind of, I think it's like 0.8. So now we're going to substitute in 0. So y equals negative 1/2 times 4 to the 0 power plus 1. So that's going to be 1. So that's going to be negative 1/2 plus 1. So that can be 2/2, and 2 minus 1 is 1. So this is going to be 1/2. So at 0, we're at 1/2. Okay, now let's substitute 1. So y equals negative 1/2 4 times 4 to the first power plus 1. So that's going to be 4. And then half of 4 is 2. So that's going to be negative 2 plus 1, which is negative 1. Now let's substitute in 2 for x. So y equals negative 1/2 times 4 squared plus 1, and 4 squared is 16. So negative 1/2 times 16 plus 1. So negative 1/2 times 16 is going to be negative 8 plus 1, which is negative 7. 5, 6, 7. So my graph is going to look something like that. And it's going to approach 1, but never cross 1. And it's going to keep growing on forever. Yeah. Okay, is there a number being added on to our equation? It's subtracted, but it's just basically like a negative 2 then. So my asymptote is at negative 2. So my graph is never going to cross negative 2. I'm going to put it in red. It's going to approach negative 2, but it's never going to cross negative 2. Alright, so I'm going to take my equation and I'm going to substitute in my values. So I'm going to have y equals 1/3 to the negative 2 power minus 2. So that's going to be the same thing as 1 to the negative 2 over 3 to the negative 2 minus 2, which then we're going to flip-flop those. So I'm going to have 3 squared over 1 squared minus 2, which what is 3 squared?
9.
So 9 minus 2, which is 7. So at negative 2, we're at 7. 1, 2, 3, 4, 5, 6, 7. Okay, now let's substitute in negative 1. So we have y equals 1/3 to the negative first power minus 2, which is the same thing as 3 over 1 minus 2. And what is 3 minus 2? 1. So at negative 1, I'm at 1. Now let's substitute in 0 for x. So y equals 1/3 to the 0 power minus 2, which is the same thing as 1 minus 2. Anything to the 0 power is 1. And what is 1 minus 2? Negative 1. So I'm at negative 1. Now let's substitute in 1 for 1/3. So I'm going to have y equals 1/3 to the first power minus 2, which is the same as 1/3 minus 2, which is negative 1 2/3. So at negative 1 2/3, it's like right there. We don't have to be perfect. I'm not asking you to be perfect on these plotting points, of the in-betweens, because you're providing them for me. Now let's do 2. So 1/3 squared minus 2, which is equal to 1/9 minus 2, which is equal to negative 1 8/9. So again, that's negative 1 8/9, which is even closer to 2, but not quite there. So then we're going to draw our graph, and there you go.